class, we'll be looking at tetravalency and catenation. Okay? Now, first of all, let's talk about carbon. Carbon has atomic number 6. Okay? The electronic configuration for carbon is 1s2, 2x2, and 2p2. This is the configuration at the ground state. Okay? This is the configuration at the ground state. Now, when carbon is excited, when you excite carbon, okay, let me just write it here, ground state. This is the ground state configuration. Okay? So when you excite carbon, electron from the 2s will migrate to the what? 2p2 to balance this p orbital to the what? Partially filled, right? So what I'm going to have here becomes 1x2, 2x1, 2p3. So at this excited state, we have 2 electrons in the 1x2, and we have 1 unpaired electron in the 2x, and while we have 3 unpaired electron in the what? In the 2p. Okay? Now notice that we have what we call 4 unpaired electron here. Okay? So how many unpaired electrons is here? 1, 2, 3, 4. Now, these 4 unpaired electrons will be used by carbon to form a covalent bond because they need to become paired for them to become stable. So the ability of carbon to connect to 4 things or to pair with 4 things, 4 different things or the same thing, is what we call tetravalency. So the tetravalency has to do with what? The valency of carbon. The valency of carbon is 4. And why is the valency of carbon 4? It is 4 because carbon needs to bond with 4 things to become stable. Okay? So this idea can also be used to explain the fact that carbon is tetravalent. So carbon, being tetravalent, can connect to 4 things. Okay? So, and this phenomenon is called tetravalency. The next one is called catenation. What is catenation? Before we talk about catenation, let us talk about carbon as a member of the group 4 elements. Carbon belongs to group 4, and what is peculiar to group 4 elements are covalent bonding. And because carbon can undergo covalent bonding, it has the ability to share electrons with its fellow carbon. So it means that carbon can connect to another carbon because they can share 2 electrons here. Carbon can also connect another carbon here because they can share 2 electrons here. They can also go to the point of sharing 4 electrons. So 2 will come from here, 2 will come from here. So carbon can keep doing this, So carbon can keep forming chains. These chains can either be straight chain or in a cyclic form. Let's say something like this. So carbon can do this. Carbon can also do this. Okay? Carbon can do this. Okay? So the ability of carbon to form chains or rings owing to its covalent nature, is what we call catenation. So the ability of carbon to connect to or form chain with itself as a result of covalent nature of carbon is what we call catenation. And this catenation is seen in carbon. You can polymerize carbon to long chains, and this is as a result of what? Catenation. Carbon is not the only element that can do that. Other elements can do that, but carbon has tendency of doing that for a long time. Nitrogen can catenate, but carbon is known for catenation because of its consistency to keep forming chains, multiple chains, as you keep joining them. Okay? So today we are just looking at the concept. What is tetravalency and catenation? I believe that you have understood what I meant by tetravalency and catenation.